So 193A. I'm going to work a sample problem because some of these transformations are a little bit confusing. So I'm going to just put some random points on here. First of all, is that a function? Yes. How do you tell? Passes the vertical line test. So let's call this function f of x. So if I wanted to graph f of x plus 1, what is that going to look like? So it says add 1 to every x value before you plug it into the function. So that's going to have the effect of moving the graph to the left 1 unit. Okay? Now, why does it work backwards? And it's saying, essentially it's saying, what x values can I add 1 to create the original graph? So the blue graph is the graph that is needed to add 1 to all the x's to create the green graph. Does that make sense? The function creates the shape of the graph, but the x plus 1 inside says what values can you add 1 to on the x-axis to create the graph that you had with f of x. Does that make sense? So if I compare f of x plus 1 to f of x, this is saying which graph do you add 1 to the x's to create that graph. And that's why everything on the x-axis works backwards. All right? What if I wanted to graph f of x minus 3? So if I take this graph, I'm going to grab that and shift it down 3 units. Now, why did it work exactly like we would expect it to work? Well, the negative the negative is outside the function, so we're adding it to the y values. So if you notice, this point here, negative 1, 2, 3, 4, 5, negative 5, comma 2. That's my x, and that's my y. F of x minus 3 says subtract 3 from the y values, also known as the f of x values. So that point becomes negative 5, negative 1. Does that make sense? So this point here, which is negative 2, 1, 2, 3, 4, 5, negative 2, comma 5, becomes negative 2, comma 2, which is, I didn't draw it very well, but would be right there. Okay? It gets a little bit harder when you start reflecting and you start doing multiplications. So let's back up to my original graph. All right, what about negative f of x? What does that do? It reflects over the x-axis because it says change all of the f of x numbers, or the y value numbers. So this is negative 5, 2. This point would be 2, 5. This point is 1, negative 3. This point is 1, 2, 3, 4, 5, comma 2. Let me lock all those in place so I can make this a little bit easier. Okay, so what it says is go through and negate all of the y values. So this would be plus. So negative 5, 2 becomes negative 5, negative 2. 2, 5 becomes 2, negative 5. And this one is going to reflect to there because the 3 becomes positive. And then this is going to go here. And then if I connect the dots, you can see these reflected straight across the x-axis. And every point in between did the same thing. Okay? So what about f of negative x? you're going to make all the x values negative. So negative 5, 2 becomes 5, 2. So this one moves to there, and that one's going to move back here. This one is going to move to here, and this one is going to move to here. And that graph is the exact, it's kind of hard to see, but it's going to look like this. That graph is an exact y-axis reflection of the original. Okay? So what about 2f of x? We're going to multiply all of the y values by 2. So negative 5, 2 becomes negative 5, 4. 2, 5 becomes 2, 10. 1, negative 3 becomes 1, 6, negative 6. And 5, 2 becomes 5, 4. So if I draw that graph, what happened? Well, my original y values, so this value, this value, this value, and that value, the distance from the x-axis doubled. So I can take this space, oh, they're all connected, sorry. So that was a double, this was a double, that was a double, and that was a double. So if I change this to 1/3 f of x, what's that going to do to the graph? It's going to be 1/3 as tall. The y values are all going to be cut into 1/3. So instead of 2, it's going to be 2/3. Instead of 5, it's going to be 5/3, which is like 1.6. Instead of negative 3, it's going to be negative 1, and instead of negative 2, it's going to be 2/3. So you can see that graph is 1/3 as tall as it was before. And then, in my opinion, the most confusing one is f of 2x. What happens when you multiply the x's by 2? Well, you would think it's going to get 2 times further from the y-axis, but remember, that multiply by 2 happens before you plug it into the function. So it's saying, what graph do you have to double its width in order to create the green graph that's already there? Does that make sense? So is there a graph that you can double its width and get this graph that's already there? It's a graph that's half as wide. So we would have to cut the x-axis in half. So there, and here, and that's 5, so there. Because that 2 happens before you plug it into the function, it's saying what graph can be doubled in width to create the green graph. So remember, everything on the x-axis works backwards. Multiplying by 2 cuts it in half. Hang on, we'll get to that. So what about f of 1/3 x? What's that going to do? So what graph can we cut into 1/3 and create the green graph that's already there? A graph that's 3 times as wide. So this 5 becomes a 15. This negative 5 becomes a negative 15. The negative 2 becomes negative 4, and the 1 becomes a 2. Oh, it's not 4, it's 6. You're right. So this should be over here. So multiplying by 1/3 on the inside will make it 3 times wider. So just remember that the x-axis works backwards. Well, what if we do several of these at the same time? So what if we did 2 f of x minus 1 plus 3? How is that going to work? So it's going to, so I'll take this graph here, move it up 3, move it to the right 1, and then make it twice as tall. I wonder if I can break that. So like that. Does the order matter? Yes. However, it's really confusing to figure out exactly which one works, and I don't believe they're going to give you anywhere order makes much of a... The only time it really matters is when you do... No, it's not going to matter. We'll just say that. The order is not going to matter. In this case, if I made it twice as big, right 1 and up 3, is that any different than right 1, up 3, and twice as big? No, those are all the same. So there are some specific cases where you're multiplying, where you're reflecting across the y-axis, where it matters, and reflecting across the x, but I don't think they're going to do that to you. I don't know. We'll see if you have any problems. So the 193A is 21 to 35 odd. That's your set for today. Okay. I do want you to draw a rough sketch of the graph. You don't have to label every point, but yeah, you do need to draw the graph. If you can find some. I don't know if I still have any. But yep. Good luck.